Welcome to Procedural Cave Generation Episode 4. So today we're going to be taking our 2D mesh and adding in a third dimension by extruding out some walls. So in order to do this, we need to devise a way of determining whether an edge is an outline edge. So say we pick a vertex, we can now see which triangles this vertex belongs to. So in the case of this one highlighted in white here, it belongs to triangles A, B, and C. Now let's pick a connected vertex to form an edge. And if we look at the triangles that this new vertex belongs to, we can see that the two vertices have two triangles in common. Now we can clearly see that this is not an outline edge, so let's pick a different vertex to actually form an outline edge this time. And here we can see that the two vertices have only one triangle in common. And so we arrive at our definition for an outline edge, which is two vertices which share exactly one triangle. Now I made a small oversight in the previous episode in thinking that it doesn't really matter with which vertex we start when we're adding our triangles, as long as we sort of go in a clockwise order. But in fact, when we're doing our outlines, we need the outline edge to always be going in the same direction. So for example, in this triangle, the outline edge would be the edge between vertex A and vertex C. So if we were to start with vertex C and add the triangle CAB, then the direction of that outline edge is from C to A, whereas if we start with vertex A and go ABC, now the direction of that outline edge is from A to C. Alright, so to start off with, let's go into our mesh generator script and just fix up these first three cases over here, case 1, case 2, and case 4. Which I made a little bit of a mistake on last episode. So instead of going from center bottom to bottom left to center left, we're going to start at center left and go to center bottom and finally end up at bottom left. In case 2, we're going to go from bottom right to center bottom to center right. And in case 4, we're going to go from top right to center right to center top. Alright, and if we run the script, our rendering should all still be fine, just make sure on that. But now our outline directions are consistent. Alright, so the last thing that I want to do before we actually begin generating our walls is to be able to specify some border of wall tiles that just goes all around our generated map. So in order to do this, let's go into our map generator script, and just below the part where we've smoothed the map in the generate map method, let's create an int to hold our border size, which I'll set equal to say 5. And then we can create a 2D integer array called our bordered map. This will be equal to a new 2D int array, and for the x size we can have width plus border size times 2, because we want the border size on both the left and right side, and height plus border size times 2. Now we want to loop through our bordered map and set everything equal to the map that we've just generated, except of course for the border, which we want to set equal to 1, which is our wall tile. So let's do a little for loop. I'll just copy this for loop over here to save time. Paste it in. So we obviously want to loop through all of the elements in our bordered map. So we'll say x less than bordered map dot get length 0 and bordered map dot get length 1. Alright, so now let us check if our x is greater than or equal to border size, and x is less than width plus border size. That means that in our loop, our x value is currently inside of the map. It's not in any of the borders. And we can do the same check for the y-axis. Y is greater than or equal to border size, and y is less than height plus border size. Then we want to set our bordered map equal to the map in that position, which would be x minus border size and y minus border size. Alright, and if we're not inside the actual map and we're inside our bordered area, then we'll set bordered map simply equal to 1. Alright, and finally, when we call meshGenerator.generateMesh, we'll instead pass in our bordered map. And now we should see that we have a nice little border around our map, and we can obviously change that size. I could make this equal to 10. And the border, unsurprisingly, is bigger. For the wall generation to work, we just need to set it equal to at least 1. Okay, so let's head back to our mesh generator script, and I'm going to scroll down. Let's delete this onDrawGizmos method. We're not going to need that anymore. And instead, I'm going to create a struct called triangle, which is just going to hold 3 public integers, a vertex index A, and as you may have guessed, the next 2 are going to be vertex index B and vertex index C. And we can create a constructor, and that will take in 3 integers, integer A, integer B, and integer C. And we can quickly assign these. Vertex index A is equal to A, index B is equal to B, and C is equal to C. Alright, now as I was demonstrating at the beginning of the video, given a certain vertex, we need to be able to tell which triangles that vertex belongs to. So we are going to create a dictionary, which we do by simply typing dictionary. Now, dictionary takes in 2 things. It takes in a key and a value, and so basically how it will work is we'll pass in an integer for our key, which will be our vertex index, and the value that we'll get out will be a list of all the triangles that that vertex is a part of. So we tell it that we want an integer as our key, and for our value we want a list of triangles. Alright, just close that off, and we can call this our triangle dictionary, and just set this equal to a new dictionary, just like that. Alright, so now let's go down to our create triangles method, and let's create a new triangle called something like triangle, and we'll pass in a.vertexindex, b.vertexindex, and c.vertexindex. Now let's also create a new method to help us adding a triangle to our dictionary. And this can take in an int for the vertex index that we want to use as the key. Let's just call that vertex index key, and a triangle for the triangle to which that vertex index belongs. Alright, now what we first want to do is to check if the triangle dictionary already contains that vertex index as a key, and if it does, then we will just add this triangle to the list of triangles already containing vertex index. Otherwise, we'll have to create a new list of triangles. So we do this by saying if the triangle dictionary contains key, vertex index key, then triangle dictionary with a key of vertex index key. So this accesses the list of triangles to which we want to add our new triangle. Alright, otherwise we want to create a new list of triangles. You can call just triangle list, and to that list we want to add triangle, And finally, we want to get our triangle dictionary, and we want to add vertex index key as the key, and triangle list as the list of triangles. Alright, so now in the create triangle method, after we've created this triangle, we're going to want to call add triangle to dictionary 3 times. The first time it will be with triangle.vertex index A is the key, and we pass in triangle, and the next time with vertex index B, and the next time with vertex index C. Alright, so let's see if using the information we've now stored in triangle dictionary, we can create a method, bool is outline edge, that will tell us, given 2 vertex indices, vertex A and vertex B, whether the edge formed by these 2 vertices is an outline edge or not. So once again, as I explained in the beginning of the video, the way we'll be doing this is by getting a list of all the triangles to which vertex A belongs, and we'll see how many of those triangles contain vertex B, and if vertex A and vertex B only share one common triangle, that means that it is an outline edge. So, to start off with, we'll get the list of triangles that vertex A belongs to, and we can call this triangles containing vertex A, and we get this by saying triangle dictionary with the key of vertex A. And now let's create an integer shared triangle count, which starts at 0, and we can loop through. We can say for int I equals 0, I less than triangles containing vertex A dot count I plus plus. And now what we'd like is to have a easy way of determining if our triangle contains a certain vertex index. So let's create a public bool inside of our triangle struct called contains, which takes in an integer vertex index, and we want to see if vertex index is equal to either index A, index B, or index C. So we can just return vertex index is equal to vertex index A, or it's equal to vertex index B, or it's equal to vertex index C. Alright, so now we can say if triangles containing vertex A contains vertex B, then we want to increase our shared triangle count by 1, and if the shared triangle count is greater than 1, then we just want to break, and at the end of the method we can say return shared triangle count is equal to 1. So if there's only one shared triangle, it will return true, otherwise it will return false. Alright, so the next thing we want to do is to create a method which, given an outline vertex, can find a connected vertex which forms the outline edge. So we want this method to return an integer for the index of the vertex that we're trying to find, and we can call this method getConnected outline vertex, and we'll pass in the vertex index. So we want to get a list of all the triangles containing the vertex index, which we can obviously do using our dictionary. So we say list triangle, triangles containing vertex is equal to triangle dictionary with vertex index as the key, and we want to loop through each of these triangles. So we'll do another for loop for int I equals 0, I less than triangles containing vertex.count I++. Here we can say that our triangle is equal to triangles containing vertex I. And what we want to do now is to look at each of the vertices in this triangle. So that would be vertex index A, B, and C. And we'll pass that vertex along with this vertex index into the isOutline edge to check if those two vertices form an outline edge. And if they do, we'll return that index. So there are 3 vertices in a triangle, so we'll say for int j equals 0, j less than 3, j++, and we can say int vertex b is equal to triangle j. Now, at the moment, triangle j doesn't actually mean anything, but it would be very useful if we could access the vertices of our triangle like an array. So we can do this using an indexer. So what we'll do is we'll create an integer array of vertices in our triangle struct, and in the constructor we'll say vertices is equal to a new integer array with the size of 3, and we'll say vertices 0 is equal to A, and vertices 1 is equal to B, and vertices 2 is equal to C. And now we create our indexer, which looks like this. We say what we wanted to return, so that would be a public integer, and then we say this, followed by square brackets, int I. And now we can say get, and we can return vertices I. And that means that we can now access our vertices from our triangle like an array. Alright, so now what we want to do is we want to say if isOutline edge, passing in vertex index and vertex b. If it is an outline edge, then we will return vertex b. And if at the end of this we haven't found any connected vertex that forms an outline edge, then we'll just return -1. Now obviously, since each of these triangles actually contains vertex index, that means that at some point vertex b is going to be set equal to vertex index, and we don't want to check outline edge with vertex index and vertex index, since that's nonsensical. So before we check if it's an outline edge, we'll just make sure that vertex b is not equal to vertex index. And if it's not, then we can proceed. Okay, so let's go up to the top of our script, and we want to create a variable in which we can store our outlines. So we know that there could easily be multiple outlines, so it's going to need to be a list. And we want to store each outline as a list of vertices. So it seems to make the most sense to create a list of integer lists to store all of our outlines. Right, and we can just set this equal to a new list of integer lists. We also know that we're going to be looking at a lot of vertices, so as an optimization we want to make sure that once we've checked a vertex, we never actually check it again. So we're going to create a hash set of integers called checked vertices. This is equal to a new hash set of integers. And the reason we use a hash set instead of, say, just an ordinary list is just because it's much quicker to do contain checks on a hash set than it is to do them on a list. Alright, so let's go down to where we're keeping all of our outline methods, and let's create a void called something like calculate mesh outlines. And what this is going to do is it's going to go through every single vertex in the map, and it's going to check if that is an outline vertex, and if it is, then it's going to follow that outline all the way around until it sort of meets up with itself again, and it will then add that to the outlines list. So for int vertex index equals 0, vertex index less than vertices dot count, vertex index plus plus. We can now say if not checked vertices dot contains vertex index, then int new outline vertex is equal to get connected outline vertex of this vertex index, and if one does exist, in other words, if the new outline vertex is not equal to -1, remember we return -1 if we couldn't find a connected outline vertex. So if it's not equal to -1, then we're going to add the vertex index to the checked vertices hash set. So add vertex index, and we can create a list of integers for our new outline. And we can say new outline dot add vertex index. Next, we will add this new outline list to our list of outlines. So outlines.add new outline. And then we're going to call a method that we haven't created yet called followOutline. And we'll give it our new outline vertex. And we also want to tell it the index of the outline that we're currently busy with. So that will be outlines.count -1. And finally, having followed the entire outline and adding all of the vertices to the outline list, we want to, at the end, say outlines dot count -1 dot add our original vertex index to go all the way around to the starting vertex. Now this follow outline method is pretty straightforward. Let's create it quickly. Void follow outline. Follow outline. It takes in an integer for the vertex index and an integer for the outline index. And the first thing we want to do is we want to add the vertex index to our list of outlines. So we can say outlines outline index dot add the vertex index, and then so that we never check the same vertex index again, we'll add it also to the checked vertices hash set. So add vertex index. Then we want to create an integer for our next vertex index. This will be equal to get connected outline vertex, pass in vertex index, and if the next vertex index is not equal to -1, then we will continue following the outline. There's not meant to be an S on the end there. We'll continue following the outline, and we'll pass in the next vertex index and the outline index. Okay, so that's the follow outline method finished. We should now have all of the information we need in order to actually create our wool mesh. But before we go ahead and do that, there are two optimizations I quickly want to make. The first is in the getConnectedOutline vertex method. We're saying don't bother to check if it's an outline edge if vertex b is equal to vertex index. We can also say and not checked vertices dot contains vertex b. That's the one optimization. The second is in the triangulate square method. With case 15, where all 4 points of the square are active, that means that all surrounding nodes are walls. In other words, none of these vertices listed here can be outline vertices, so we can just go straight ahead and add these to the checked vertices hash set. So checked vertices.add square.topleft.vertex index, and I'll just copy and paste this so that I've got 4 copies. I can say square.topright, square.bottomright, and square.bottomleft. Alright, so with that done, we can go to our generate mesh method, and at the top, let's start off by saying outlines.clear and checked vertices.clear, so that we reset these 2 variables each time we generate a new mesh. And then at the bottom, we can say create wall mesh, and let's create this void method, create wall mesh. In here, we're going to want to create a list of vector 3s for our wall vertices, as well as a list of integers for our wall triangles. And then we're also going to want to create a mesh, wall mesh, equal to a new mesh. And finally, let's create a float for our wall height, which I'll just set equal to, say, 5 for now. Then we're going to want to go through every outline in our outlines list. So we can say for each integer list outline in outlines. Now we want to loop through each vertex in that outline, so we'll have a for loop int I equals 0, I less than outline dot count -1, and the reason we do -1 here will become apparent in a few moments. I++. Alright, so now we want to start off by creating an integer called our start index, which is equal to the number of items that we have in our wall vertices. So wall vertices.count. And then we'll add 4 vertices to the wall vertices array, the top left, top right, bottom left, and bottom right vertices, which will sort of make up the little sort of section of the wall that we're working on. So we'll say wall vertices.add vertices to get the position of outline I, and we can call this the left vertex, and let me just copy this. Then for the right vertex, this will be outline I +1, and there's the reason why we go to -1, because we want to get the next one here. So if we went all the way up to outline.count, we'd get a out of bounds error. And now let's copy these 2 to get bottom left and bottom right. So these are the bottom vertices of our wall. So here we'd want to subtract vector3.up multiplied by wall height, and the same thing here, minus vector3.up multiplied by wall height. And now we need to assign these indices to our wall triangle list in the correct order. So since the walls will be viewed from inside, instead of winding them clockwise, we'll wind them anti-clockwise. So we can say wall triangles.add, we'll say start index. So let's say we start with the left vertex, so it'd be start index plus 0. Of course, plus 0 isn't really doing anything, I'm just writing that to make it clear. Then we could go to the bottom left, which would be 0, 1, 2, so plus 2. And we'd then want to go to the bottom right, which would be plus 3. Alright, so that's our first triangle, and then we want to add our second triangle, which we could start at, and so we started at bottom right, which is plus 3. We could then go to top right, plus 1, and then we could end off at top left, which is plus 0. Alright, so now at the end of that, we just need to say wall mesh dot vertices is equal to wall vertices, and we need to convert that to an array, so we say toArray, and wall mesh dot triangles is equal to wall triangles dot toArray, and having done that, we want to actually assign this wall mesh to an actual mesh filter. So let's create a public mesh filter, which we can call our walls. And over here we'll say walls.mesh is equal to the wall mesh. And at the top of create wall mesh, we first, of course, going to want to call that method calculate mesh outlines. Okay, so let's see if this is working. We're going to want to create an empty child under the map generator, which we can call our walls. And let's add a mesh filter and a mesh renderer component to this. And let's create a new material, call this the walls. And let's make this a slightly different color, like that. And we can apply this to the materials of our wall mesh renderer. And we can drag this onto the walls mesh filter. Now let's save in case everything crashes and press play. Okay, so we've got some nice walls being generated. I'm just a bit concerned though, if we generate now a new map, yeah, as you can see, things go completely crazy. I think what I forgot to do was over here when we clear the checked vertices and the outlines, we also need to clear our triangle dictionary. So we can just say triangle dictionary.clear. Alright, now if we go back and run this again, you can see we can generate walls for any map. Alright, so that brings this rather long and complicated episode to a close. If you have any questions, don't hesitate to leave a comment. And until next video, cheers.